Have you ever just stopped and wondered, why are some countries so incredibly wealthy while others seem to be permanently stuck? It's one of the biggest, most important questions in all of economics. And today, we are going to deconstruct it piece by piece. We'll be looking at the three major theories that have tried to explain this huge gap in global prosperity. Let's dive in. So, what is the secret sauce for economic growth? Is it all about having natural resources, a giant workforce, or is it something else? We're about to go on a journey through economic history to find out. We'll explore three very different models: the classical, the neoclassical, and the modern endogenous growth theory. And you'll see how each one builds on the last, giving us a clearer and clearer picture of what's really going on. All right, Act 1. Our story starts way back in the late 18th century with a really pessimistic view from a guy named Thomas Malthus. This is the classical theory of growth. And believe me, its conclusions were so bleak, so grim, that they literally earned economics the nickname the dismal science. Let's find out why. To really get the logic here, just picture a simple village. And this village has a fixed amount of farmland. That's it. You can't just snap your fingers and make more land. So what happens when more and more people are born in this village? Well, it's pretty intuitive, right? Zameen utni hai, par log बढ़ते जा रहे हैं. The land is constant, but the population is growing, so every person's slice of the pie gets smaller. That simple idea is the entire engine behind the Malthusian trap. Okay, here's a critical term we need to understand: subsistence income. Think of it as the absolute bare minimum you need to survive. But here's the twist. In Malthus's world, this wasn't just a poverty line. It was an automatic trigger. The second the average income went even a tiny bit above the survival level, people would start having more kids, and the population would boom. This link is the key to the whole trap. And this slide right here, this lays out the inescapable doom loop that Malthus described. Let's walk through it. So, step 1. Someone invents a better plow. Great, that's a tech advance and incomes go up. For a little while, life is better. But that triggers step 2. That higher income means more kids and the population explodes. Now we hit the wall in step 3. You've got all these new people crowded onto the same old piece of land. That's diminishing marginal returns. Each new person adds less and less to the total harvest. And that leads inevitably to step 4. Productivity per person just tanks, dragging the average income right back down to that miserable subsistence level. And there it is, the model's really grim conclusion. In the long run, any cool new technology doesn't actually make us richer, it just makes us more numerous. Every single innovation just gets gobbled up by population growth, leaving everyone stuck at the same bare survival level forever. You can see why they called it the dismal science, right? It was basically a forecast of permanent human misery. So obviously, Malthus was wrong. Humanity escaped. But the question is, how? Well, it happened for two massive reasons. First, that core assumption he made, that more money equals more kids, it just broke. In fact, the opposite happened. As countries got richer, their population growth actually slowed down. And second, the Industrial Revolution unleashed an absolute tidal wave of innovation. It was so fast and so powerful that it just blew past the problem of diminishing returns. Progress wasn't a temporary blip anymore. It became a sustained, powerful force. Okay, for all of you studying for an exam, here's your strategy. If you're reading a question and you see words like Malthus, subsistence income, or anything about population growth overwhelming a fixed resource like land, ding, ding, ding. That's your cue. You are in the classical model, and this is the logic you need to apply. So, the Malthusian trap fell apart. This sent economists back to the drawing board, which brings us to Act 2. In the 1950s, an economist named Robert Solow developed what we now call the Neoclassical model, and it completely changes the focus. We're not talking about fixed land and population anymore. We're talking about two new engines of growth: capital and technology. Let's go back to our village, but this time we're adding something new: tractors, what economists call capital. Now, that first tractor, it's an absolute game changer, a revolution. The second tractor helps for sure, but not quite as much. By the time you get the 10th tractor, it's probably just sitting in the barn half the time. It's that same intuitive idea. Pehla tractor bahut kam ka tha, par 10waं utna nahi. That first one was a miracle, but the 10th one, meh. This is the heart of the Solow model, diminishing marginal returns. But this time, it's applied to capital. But the Solow model has this other character, a really mysterious one, called total factor productivity, or TFP. The best way to think about TFP is that it's the recipe. It's the knowledge, the efficiency, the secret sauce we use to combine our workers and our machines. But here's the weird part. In this model, TFP is treated like a magic ingredient that just appears. It's exogenous, meaning it comes from outside the economic system. It's all the growth that's left over after you account for simply adding more workers and more machines. And now for the technical stuff. The engine of this whole model is this production function. Don't let it scare you. Y is just our total economic output, and it's created by three things. K is our capital, our tractors. L is our labor, our workers. And A, that's our magic ingredient, total factor productivity. See how A is a multiplier? It just makes all our existing capital and labor better. The little alpha symbol just tells us how important capital is in the whole process. That number is going to be super important in a minute.
Okay, let's build one of the key formulas step by step. What we really care about is how much capital we have for each worker, because that's what makes people richer. So, step 1, we start with our total new capital. That's our investment, a percentage S of our output, minus the old stuff that breaks down, which is depreciation, or delta. Simple enough. But step 2, we have to spread that new capital across more people because the workforce is growing. तो हमें नए workers के लिए भी capital provide करना होगा. We have to give the new guys, N, their own tractors. And that gives us step 3, the final formula. The growth in capital per worker is what we invest, minus what we lose to depreciation, and what we have to give to new workers. And that formula leads us to the absolute central idea of this model, the steady state. This is the long-run balance point. It's the point where our brand new investment is just barely enough to replace the old machines that break down and to equip the new workers joining the force. At this point, the amount of capital per worker stops growing, and the model says that every economy, no matter where it starts, is naturally drifting toward this equilibrium. And all of that logic brings us to what I call the hero formula. This is the single most shocking conclusion from the Solow model. In the long run, the growth rate of income per person, it only depends on the rate of technological progress. Look really closely at what's on the slide. Now look at what's missing. The savings rate, S, it's not there. This was a bombshell. It means that in the long run, saving and investing more does not make your economy grow faster. It's all about that magic ingredient, technology. So that probably has you scratching your head, right? I mean, if saving more doesn't make you grow faster in the long run, then why is every economist on the planet always talking about how important investment is? What actually happens if a country decides, you know what, we're going to save a lot more? Okay, this is the crucial distinction you have to get. It creates a level effect, not a growth effect. So as you see here, if you increase your savings, you get a temporary boost in your growth rate. The economy speeds up for a while as it moves to a new higher path. The end result is a permanent increase in the level of your income. The country will be richer forever. But, and this is the absolute key, it has no effect on your long-run growth rate. Once you get to that new, richer path, you go back to growing at the same old speed, a speed that is only determined by technology. And this isn't just a theory, you can see it in real-world data. Take a look at China. Its actual potential growth is way higher than its calculated long-run steady state. What does the model say? It says China is in that high-growth catch-up phase. It's moving to a new, higher level. Now look at Japan and Ireland. Their potential growth is almost exactly the same as their steady state rate. According to the model, they've already arrived. They're mature economies just cruising along at their long-run speed limit. All right, time for your exam strategy. Key words like Solow, steady state, and convergence are your first big hints. But the absolute dead giveaway for a neoclassical question is any scenario where changing the savings rate leads to a permanent change in the level of income, but has no effect whatsoever on the long-run growth rate. If you see that, you know you're in Solow's world. So the neoclassical model was a huge step forward, but it left this giant, gaping hole in the middle of the theory. If long-run growth is all about technology, well, where does technology come from? The model just treated it like this mysterious black box. Our third and final act, Endogenous Growth Theory, is all about prying open that box. The core idea here is so simple, but so powerful. Technology is not some magic dust that just falls out of the sky. It's something we create through deliberate investment. You know, technology आसमान से नहीं गिरती, हम उसे बनाते हैं. We build it. We spend money on research and development, we educate our people, we build human capital, and these choices are what generate the innovations that drive growth. This makes technology endogenous. It comes from inside the system.
And this leads to a really cool concept, positive externalities, or what we usually call knowledge spillovers. Think about it. If a company builds a new factory, they get the benefit from that factory. But if a company discovers a new bit of code or a new scientific principle, that knowledge can't really be contained. It spills over. Other firms see it, they learn from it, they build on it. This means the benefit to all of society from investing in ideas is way, way bigger than the benefit to the single firm that made the discovery. This table nails the huge shift in thinking. Let's go down the list. Where does tech come from? Magic versus man-made. What are the returns to capital? In the old model, they diminish. In the new one, they can be constant for the whole economy, thanks to those spillovers. But here's the absolute game changer, the role of savings. In Solow's world, it only affects your level of income. Here, in the endogenous model, saving and investing more can permanently, yes, permanently, increase your growth rate. And that totally changes the story about whether poor countries will automatically catch up. Now, the formula for endogenous growth looks pretty similar, but the change is revolutionary. See that C, the marginal product of capital? It's now treated as a constant. Why? Because the theory assumes that those knowledge spillovers from new investment perfectly cancel out the old problem of diminishing returns. And look what that does. The savings rate, S, is now directly and permanently a part of the long-term growth equation. The implication is huge. You save more, you invest more, and your economy will grow faster, forever. And the difference this makes is just massive. To put a real number on it, this model suggests that a sustained increase in a country's investment in R&D and human capital could make its per capita income almost 28% higher in just 1 decade. That's not a temporary boost that fades away. That's a whole new, permanently faster growth path. It makes policies that encourage innovation and investment incredibly powerful. And here's our final exam strategy. If you see words like R&D, human capital, or knowledge spillovers, you're almost certainly in an endogenous model. But the absolute killer giveaway is any question about a policy like a government subsidy for research that leads to a permanent increase in the long-run growth rate. That is the soul of endogenous growth theory. So after this whole journey through 3 different eras of economic thought, let's circle all the way back to our huge opening question. Will poor countries automatically catch up to rich ones? This is the great convergence debate. And as we've seen, our theories give us 2 very different answers. Now, the neoclassical argument for convergence, for catch-up, is super intuitive. This chart shows it perfectly. In a developing country where there are hardly any tractors, that first one is a miracle. Its marginal product is enormous. But in a developed country that's already full of factories and machines, one more piece of equipment has a pretty small impact. So the logic is investment should be way more profitable in poorer countries, which should make capital flow there, making them grow faster and naturally close the gap. And this leaves us with 2 totally different predictions for the future of the world. The neoclassical view is pretty optimistic. It says, yes, convergence is built into the system. Diminishing returns create this natural catch-up mechanism. But the endogenous view is way more cautious. It suggests that rich countries can keep investing in knowledge and stay ahead of the pack, meaning convergence isn't guaranteed at all. In fact, the gap could even get wider. And so we're left with this final, really powerful question. Is our economic future a matter of fate, or is it a matter of choice? The classical model told us our fate was sealed in misery. The neoclassical model said our growth was determined by some external, magical force we couldn't control. But this newest theory, endogenous growth, it argues that our destiny is actually the sum of our choices. How much we decide to invest in ideas, in education, in innovation, it puts the power and also the responsibility for creating prosperity right back in our own hands. Thanks for joining me for this explainer.